Hi there, and welcome to this talk about how to keep alive your TypeScript definition using Zod. First of all, who I am. I'm Luca Del Puppo, a full-stack developer at Floin, a company part of Clarinet, and a Microsoft MVP. These are my contact, and if you want to chat with me or if you want to ask me anything, they are open and you are welcome. But let's start with the talk. Today, I wanna speak about TypeScript and its journey and how we can prevent problem with it. So, almost 10 years ago, born TypeScript, and the reaction of all the JavaScript developer was like that. We were happy, and then we start to convert our application from JavaScript to TypeScript. So we start to create interface to map model like a DTO or something else, or we start to using types. Types or interface are similar, but we can choose the best for us. After that, we start to integrate our application with the backend. So we start to create HTTP requests. When we are in our editor, all it's okay, I suppose. But after a while, someone in the backend application start to refactor the application or remove or add or change the API. So one day in the front-end application, we start to see strange string like that. So not a number, unexpected string, and so on. This because TypeScript is good, but work only in our editor and until the build phase. The reason why is are these. So TypeScript enabled type check, but only during the build time. So after the build, all the types disappear, and all the consideration that we make with our type dissolve. So how can we prevent this kind of problem? Probably this problem is not a problem if you know JavaScript, but if you know Zod, you can prevent it without any problem and get the best experience also for your TypeScript flow. Zod is an NPM library, and you can install it using npm. And Zod is our superhero to keep alive our TypeScript definition. So after install it, we have to create a schema. A schema in Zod is a JavaScript object where we can describe as our type could be. In this case, after install Zod, we can import it using import Z from Zod, and we can create our schema using a different method. In this case, for instance, I create the customer schema, and the customer schema describe the customer type. In this case, customer is an object with 4 properties: ID, name, email, and phone. ID is of kind number, name, email, and phone are of type string, for instance. Perfect. As you can notice, the schema is a JavaScript variable, and I use const. So this schema rests alive also after the build. Perfect. But we wanna use this schema, but we wanna also use TypeScript. So using Zod, we can convert the schema using the type of method. The type of method permit to convert the schema in a TypeScript type. For instance, in this case, I convert the customer schema to the customer model. So you can use your type in your code base like a normal types in TypeScript. But now we have we have the schema and we have the model, but we want to guarantee our types also during the execution of the code. To do that, Zod exposes for each schema a method called parse. Parse is a method that accepts only one parameter, and this parameter is your object. If the parse is okay, the parse method returns an object, in this case res, and res is with the right type for TypeScript. For instance, in this case, the res variable is of type customer model. And you can use this parse to guarantee your type during the execution of the code. But if something went wrong, parse raises an error. This error is of type Zod error, and you can check if the error is of this type using the instance of key. If the error is of this type, inside of the Zod error, you can find all the issues that describe why your object is not like expected. Perfect. But if, like me, you hate exception, you can also use the savePass method. SafePass method is similar to the pass method, but always return an object. If the pass is okay, return an object with two properties. The first one is success, and the value is true. And the second one is data. Data contain your object with the right type. Otherwise, if the object is not okay, the savePass method return an error and an object with two properties: success with the false value, and error that contain the Zod error to understand the reason why your object not respect your types in this case. Okay, perfect. But which are the benefits of using Zod? So Zod is an NPM agnostic library. So you can use Zod in your Angular application, in your Vue application, React, and so on. You can also use Zod in the node environment to guarantee the data, the types of your post request or your put request. In this case, I focus my example for the front-end application. So using Zod, we can create a validation layer between our application and the outside. For instance, when we receive an object from an HTTP request, using Zod, we can check if the object respects our types. And if it's okay, we can continue the flow of our code. Otherwise, we can raise an error, log it in Sentry, New Relic, and so on, get a notification, and try to fix the problem as soon as possible. Using this kind of layer, so you can also prevent a problem with your user. For instance, if you expected two numbers, but you received two strings, the result could be different. For instance, if you expected two numbers, 1 and 1, in your flow, you sum this number, the result is 2. But if you receive two strings with the value 1 and 1, and you sum it using JavaScript, the result is 11. So you can also prevent wrong data for your user in this case, and react to problem in your application, for instance. Another important things you know when something is changed, and you can fix it as soon as possible. Okay, I think you have understand the benefit of have this layer in your application, so we can jump in the demo. I create two examples, one without Zod and one and another with ZOD. So the application is very simple. There is this is a React application that call an HTTP request and get a list of order. Each order could be each order has a different status, and the application show the data based on of the status. My API in this case is a simple JSON file, and I think that's all for the application. Now we can jump in the code. So if I go to my Visual Studio Code, I have prepared 3 files: the model file, the service file, and the order JSON file that is our API in this case. In the model file, for the first example, I create all the model, all the types, and I use only TypeScript. So I map my customer model using type with an ID, name, email, and so on. I create a ship model. I create the currency model with the amount of type number and the currency that is an union type between dollar and the euro, and so on. The application called the API using the fetch method. Very simple. I create a simple get order method that run this fetch. The fetch call my JSON file and then pass the result using the JSON method exposed by the fetch. And as you can notice, I used it as a keyword to guarantee the type of the result. In this example, as you can see, we suppose that the result is of type is an array of order model, but we are not sure in reality. So, which could be the problem if you use this approach? For instance, I can change my API and I change the amount of the first order. And for instance, I change amount from number to string. And I go back to my browser. In this case, if I refresh the page, you can notice that the total of the first order now, it's a bit strange. Yes, the currency is okay because it's dollar, but the amount now show the not a number value. Okay, we are developer and probably we know what is not a number, but if you are a common user of this application, not a number, it's not a known data. Another important problem of this solution is that as developer, we can get a notification if this happens. And probably the only way to get to know about this problem is a call from the customer to the call center or a call from the customer to the team. So probably you have a big picture of the problem now, and you can understand the problem of using only the type in your TypeScript application. So now we can move to the other example using ZOD. So I put the amount again to number. I stop my server and I change my branch. I restart on the application and okay. So for this example, I create the schema. So I install Node, ZOD, and I map all the schema using ZOD. For instance, I create a schema for the ISO the string. I create a schema for the customer. So in this case, the customer is an object with the four property: ID, name, email, phone, and so on. And the currency, for instance, is another object with the amount and the currency. As you can see, you can create your schema like during the creation of your type with TypeScript. So we can also create, for instance, the union type for guarantee the currency is or euro or dollar in this case. Then I change the service. Now the service use the fetch method as before and pass the data using the JSON method. In this case, the result of the JSON method is an unknown type. So then I create the result, and using the parse method, now the res is of type is an array of order model for as you can see. This is the array, and this is the union type of all the kind of the order model. So now this parse guarantee during the execution of the code that the data is of type is an array of order model, for instance. And then if I return the result, as you can notice, now the method are okay, and TypeScript detect the res is of the same type of the signature. Okay, which are the benefits of using this solution? If I change the amount from number to string, for instance, and I came back to my browser, now if I refresh the page, I get an error. And this error, I print in the DOM the ZORLD error in this case. The error describes the problem. As you can notice, in the error, you can find the path. And in this case, the path say the first element of the list has a total object, that contain the amount property. This amount you expected is the expected is a number, but I receive a string. So you can also understand which is the problem in this case. So if you receive a Boolean instead of a string and so on. Using this approach, you can catch the error and send the error to your Sentry or to your New Relic or so on. And you can get a notification that something went wrong for a user. So you can try to investigate and fix the problem as soon as possible. Then you can also create a beautiful model to notify the user that something went wrong, and maybe that he can try later to use your application. So if I put the amount again to number and I refresh the page, the result now it's okay, and so you are sure that the application run with the right type in this case. Perfect. I think from the demo that's all. Now I wanna start with my conclusion. The conclusion of this talk are these. So first of all, TypeScript is fantastic for me, and I use it in all my application without any problem. But please remember, TypeScript disappears after the build, so all your TypeScript definition become hide after the build, and your JavaScript, your code run as JavaScript code, not like TypeScript code. And how we can prevent this problem? We can prevent this problem, create a validation layer between our app and the outside. And this layer, it's helpful to prevent the execution of code with the wrong data, but also to get notification is if something is changed and the types are not like expected. How we can do that? We can do that using ZORLD. ZORLD is an NPM library that is able to guarantee your type both build time and runtime. And you can use it in all your application Angular, React, Vue, Solid, and so on. And then you can be sure that your type are the same during the build time and during the runtime of your code. Okay, I suppose you have a big picture of how to use Zod and the benefit of using it. My presentation, it's handed. In the first QR code, you can find the code, and in the second QR code, you can find the slide. I hope you enjoy. That's all. These are my contacts, and if you want to chat with me, you are welcome. Thank you very much, and bye-bye.